Hey everyone, this is a quick video to share with you the result of my rock, paper, scissors classification project. The goal of the project was to train a convolutional network on a dataset of rock, paper, scissors, hand gesture images. Once trained to implement the model inside a very simple application like this one using OpenCV to display images of my webcam. Define a range of interest here. In green, add mouse bindings so I'm able to move it around, resize it, position it to a convenient place where I can easily show my hand. And after that, enter a prediction mode where whatever pictures is inside, whatever pixel inside my range of interest are passing through the model, and the model outputs the prediction with the highest probability. So as you can see, it's working quite well on the different shapes, even on pictures displaying the hand from the back of the hand side, and some extreme or a bit inconvenient shapes. Yep, so it's pretty stable and I'm quite happy with the result. Let's have a look now at my rock, paper, scissors CNN project on GitHub. So you will find here information about the dataset I've been using to train my CNN, the model itself and how I trained it, and finally a description of the different notebooks that I've wrote to come up to these results. Most of the files are available here except the dataset and the model because they are a bit heavy, so I moved them to Kaggle. You have the dataset here and the two versions of the model here, as well as a startup notebook to test both of them. Let's have a look at the dataset I've been using to train my CNN. The first one is from Drg Freeman. It's available on Kaggle here. I think it's one of the most common one. I've seen it around in dozens of projects. It's a pretty strong dataset. I think he wrote it to play rock, paper, scissors with a Raspberry Pi. My main issue with this dataset was, first of all, that the pictures are 90-degree rotated. They are not square, and most of all, they have been shot on a green background. So I'm not really sure how confusing that is for my model to train, basically using a green background. But since my other two datasets have a grayish clear background, I thought it would be a bit confusing to basically throw those pictures inside the model. So the first thing I've been doing, I wrote this remove green screen notebook where I'm using CV2 methods basically to come around a picture and eat up the background as best as possible. So as you can see, this is an input picture, this is the output picture. What I'm doing is I'm rotating the picture, I'm pasting it inside a 300 by 300 image, which is the resolution I'm using for my three datasets. And I'm eating as best as possible the background and replacing it with this light gray one. So this is maybe not the best example, but if I show you, for example, this one, yeah, as you can see, it's not perfect, but it's definitely good enough. It's good enough for the model to train, and it's retaining all the important information about the hand. So those pictures are the ones that I'm inputting into my model. The second dataset I've been using is the one from Sani Kamal. It's also available on Kaggle here. It's a common one also. I've seen it a lot. I like it a lot because it features different variation, sometimes quite interesting shapes where the hand is not necessarily completely closed on a fist or completely open or on paper or scissors. It features also female hands. It has different, I think, skin colors. So I think it's a pretty good one, pretty strong one. Also, yeah, like extreme shapes where you're not necessarily doing what is expected of a paper shape. So It's pretty good. You can download it from here, but note that you can also find it inside TensorFlow datasets. So if you list all the datasets that are shipped with TensorFlow, you have it here somewhere. Yeah, rock, paper, scissors. So you can download it here. I have a little piece of code here that's downloading it. So it's the one from Sani Kamal. Okay, finally, the third dataset I've been using is one that I created myself. Why did I create a dataset myself? Different reason. First of all, because it's fun, obviously. But more importantly, you may have noticed on the dataset of Drg Freeman and Sani Canal that both datasets are displaying the back of the hand and not the palm of the hand. However, I mean, this might be fine if your camera is placed above your hand, but in our use case, obviously, we want to display the palm of the hand to the camera and not the back, which would be a bit uncomfortable. So I thought it would be an interesting exercise to create my own dataset and well, improve the model, make it more robust to palm hands images, using images of the palm of my hand. How I've been doing it, it's quite easy. I added to my main application. By the way, my main application is executed from the notebook RPS main, which is the main application notebook. So when I execute it, I get this window, and I added a capture module, capture mode. If I hit the C key like this, you can see now, you can see it also in my Visual Studio on the left, that everything defined right now inside the range of interest is captured as an images of 300 by 300 pixels. So this is how I've been capturing my data sets, recording many variations of my hand for the different shapes. I've recorded also my wife's hand and my son's hand to bring even more variations. The pictures are coming here on the left in the capture folder, and then I move them into the different classes. Let's have a quick look at the dataset itself. It's available here. So I shared it on Kaggle. It has about 2,700 pictures of the front and the back of the hand, and even pictures from the side of the hand. Well, that would be a bit more complex. All ordered by classes. Before talking about training the model, I want to quickly show you how I organize the three datasets, because Keras need them into a folder structure it can understand. I have the three datasets here, Alex Dijon, Drg Freeman, Sani Kamal, and I need them to train my model into a test, train, and a validation folder, each one containing my three classes. So I've been writing this build dataset Jupyter notebook that's simply randomly taking pictures from these three datasets and copying them into this train, test, and validation folder. So the notebook is going through all of the pictures and randomly copying them inside the test, train, and validation subfolders. It's doing this based on a given ratio. This is something very important you've seen around probably. So the random copying is happening following a ratio of 70% going into training, 20% into testing, and 10% into validation. I can change the ratio here and basically create those three directories accordingly. I tried different ratios, 08, 01, 01, 06, 02, 02, but this one gave me actually the best results. Okay, now let's have a look at training the model itself. For this, I have a Jupyter notebook called Train CNN. Inside, I define all the modules that I will be using, especially the Keras one that we will be using to train the CNN. I define my different subfolder paths to my train, test, and validation folder. I have a few helper methods that are not mandatory, but quite handy when you need to quickly display an image, save your model, get random pictures from the dataset, etc. That's an example picture, for example, loaded from my dataset, showing that the paths are working well. No, I'm preparing my different generators using image data generator from Keras. This is a good way to basically generate image variation from your data sets, playing around with rescaling, zooming, shearing, flip various parameters, and make the model more robust by having as input different variation. So this is, for example, from this image, what the generator is outputting. This is the architecture of my sequential model. So it has an input layer, 3 hidden layers, conv2d, max pooling 2d, the flatten layer, and my 2 dense layers. I added some dropouts of 50% of dropouts between the 2 dense layers to help reduce overfitting, which seems to be working quite well. I have seen people also put dropouts in between the hidden layers. I'm not sure if this makes sense, or it would be interesting to try. But for my use case, I actually only put it at the end in between the 2 dense layer. I tried to move my model to my GPU, to train my model to my GPU, but I wasn't able to do it. So in the end, it trained on my CPU for about 2.5 hours. And one of the last thing I've been implementing is this early stopping, because originally I trained my model for 100 epochs, but I noticed that it was starting to introduce some overfitting towards the end. So I put an early stop with a patience of 10. So if after 10 epochs you don't see any accuracy improvement, then the model will stop. This worked actually quite well. After starting my model, it trained for about 67 epochs and then stopped after 67 epochs. You can see the result here of the accuracy going quite up after during the first 10 epoch, and then stabilizing and learning, improving slowly over the remaining epochs. And if you look at the loss is going down slowly, but the validation loss is actually stabilizing. So it's stabilizing at around 0.1, 0.09. So it's not increasing again, meaning that there is no overfitting happening until this point. This is the second version of my model, the one I put on Kaggle. It's called 7, yeah, 7 inside, but it's the version 2 of the model. The confusion matrix and the classification reports are quite satisfying, in my opinion. So this is definitely better than the first version I had. And finally, I tried the model on a prediction image. So I'm loading a random image from my dataset, and it's predicting paper with an accuracy probability of 0.998, which is quite precise. And I also wrote this cell to test, basically to go through all my validation pictures here, my dataset of validation pictures, and print the prediction results. So as you can see, it has classified 700, about almost 800 pictures with a success of 98.3%, an accuracy of 98.3%, and it failed on 13 images. I found it quite interesting to print those images to understand why did it fail. And as you can see, all the images when he failed were actually shapes where the hand is shown from the side. So I mean, you could totally understand here that the model is predicting scissors or a rock on this one. So as you can see, it's kind of forgivable, except maybe this one, but the hand is cropped here. Or those one where it's a bit extreme and it's difficult to say that this is actually paper. Or like here, hand shown from the front. All right, and the last cell is actually the same application that you have here. It's creating a webcam capture and predicting on images. All right, and the last thing I would like to show you is this remove background notebook. So I've noticed that while my model is performing quite well on a very plain background like this one, it's actually performing very poorly if I put it on a noisy background like this one. So here you have the image, first of all, is blurry, as you can see, and the background is actually quite noisy, and it has a hard time. I mean, it should recognize a rock here. It doesn't. Paper works quite okay. Scissors doesn't work at all. So as you can see, because of the noisy background, it's performing actually poorly. So I thought about a solution to improve this by maybe getting rid of the background, which is something that should be easy because we can see and we can capture an empty background before showing hand gestures. And this is what I've been doing in remove background. So in this notebook, I'm playing around again, kind of like what I've done with remove green screen one. I'm using CV2 to try to detect the background, and get rid of it, and playing with the threshold method from CV2 and threshold amount here that I can increase or decrease. I can eat more or less from the background and try to retain as much as the hand as possible while getting rid of the background and replacing it with this grayish, light gray color I've been using. Once I was happy with the result, I implemented it into my main application, and it is happening now here. So I'm gonna to show it to you, I'm gonna activate a debug mode, which is a mode where I can show here at the top left what's entering my model. You also have an FPS value that's also quite interesting that I've implemented right at the end of the project. And if I hit the threshold value, the inside of my range of interest becomes like gray because it's actually, it captured the background and it's now subtracting it. So, and now if I put my hand inside, it's subtracting again the background, but my hand is not subtracted. And as you can see, now the result is working quite well. I can increase or decrease my thresholding value. So I'm decreasing it right now, and you see more of the background appearing. All right, so I found out that around a value of 20, the result is quite well. And as you can see now, it has no problem predicting even on the noisy background. And if I remove my debug layer, you can see that now the threshold is still on. It's written in the log bar at the bottom. The threshold is on, it's just hidden. And you can see that it's performing perfectly on a noisy background. However, if I now deactivate the threshold, now the threshold is deactivated, it disappeared from the log bar, and you can see that again, it's performing poorly. It cannot predict with accuracy. All right, I think we're done. We covered the different notebooks available in my GitHub project, talked about the model itself and how I trained it, and the dataset I've been using to train the model. We covered the different file also and datasets and models available on Kaggle. So you should be all set. I hope it was interesting for you. It was definitely for me a great use case to cover. And I think anyone who wants to play around and train their first sequential model should go through this one. This use case, it's an interesting and an easy one to go through. Please share with me if you have any comments on the structure of my model, if you think I can improve it somehow. Play around with the parameter. I'm still experimenting a lot. I might start playing again with it in the near future. So share. And yeah, thanks for watching. See you around very soon for more exciting projects. Bye bye.